So our experiment was elephant's toothpaste. Our group was me, Sebastian, Gio, and Colin. So how did we come up with this experiment? Our first idea was to think back on previous experiments that we had done in the past or that we had seen. And at the top of our list was elephant's toothpaste, but we didn't jump to conclusions yet. Then we decided that we had to cut out some of our ideas because we couldn't get the materials needed to do them. And then we took to YouTube to see which ideas were the most reasonable and also which ideas looked the best when presented and which ones would be fun. So obviously at the top of our list at the end of the day was elephant's toothpaste, and that's the one we ended up picking. So the larger scientific impact. So this experiment allows us to know the best proportions of hydrogen peroxide, water, and yeast, which will produce the most heat, which in the future could be used in some way to create energy. So our variables were our controlled variables were the water temperature, the amount of water, as well as the amount of yeast and the amount of soap. This means that these variables didn't change at all through our experiment. Our independent variable was the amount of hydrogen peroxide. That was what we changed. And the effect that it had was on the temperature of the reaction. Since the reaction is an exothermic reaction, that means that it emits heat, meaning that the temperature would go up as the reaction occurred.
Alrighty, so we actually had to have a very specific method for doing this experiment, or else it would not go according to plan. So we start off by pouring the hydrogen peroxide and soap into an Erlenmeyer flask, and we mixed that solution until it was combined. And then in a separate beaker, we mixed the yeast with warm water, and then we ended up pouring that yeast into the flask, and that's when the reaction would take place. And while the reaction was taking place, we recorded the temperature with a temperature laser in order to get the maximum temperature to determine, how well the amount of hydrogen peroxide that we were using was impacting the experiment. So before we actually did this experiment, we discussed our hypothesis and what we thought was going to happen, and we all came to the same conclusion or hypothesis that the temperature of the experiment would increase to a certain point, and then at that point it would essentially decrease, which would form an upside down parabola, or like an upside down like U shape. So here we actually have a video of us doing the experiment, and we'd like to play that for you right now.
32.7, 32.8, 32.9, 33, 33.1.
Alright, so this is the graph of our data. So at first it kind of started off a little cooler at 31.5 degrees, still releasing heat, and then it reached a peak of at about 130 milliliters of hydrogen peroxide, reaching a peak of 37.2 degrees Celsius. So that's when we knew that that was going to be where the reaction was going to be most efficient and going to be releasing the most heat. So analysis and conclusion. So the data followed our hypothesis that there would be a peak for the temperature of the experiment, and it did indeed follow a upside down parabola, an upside down U shape. So we found that the experiment was most effective with 130 milliliters of hydrogen peroxide. So our conclusion is that there's a peak in the amount of decomposition of hydrogen peroxide. When an excess amount of hydrogen peroxide is added, it slows down the reaction. So when there's too much hydrogen peroxide for the yeast to break down into water and oxygen, not as much is broken down, and and we were left with with lower heat, so less of the reaction takes place. So reflection. So while determining the best volume of hydrogen peroxide to create the most amount of heat in the reaction, we're able to take away significant aspects that can be related to other areas of science, such as biology, and this can be applied to creating heat in our homes and other places, or create an environmentally friendly projects in terms of getting the most efficient and most energy out of a given amount of hydrogen peroxide. And overall, we thoroughly enjoyed completing this experiment, and loved when we were designing an experiment to answer our hypothesis to be able to solve real world problems and eventually make a difference in the world.